In this example, we're going to solve three equations. In part A, we need to solve the equation x squared minus 32 equals 4. The first step in solving this equation will be to isolate the x squared by adding 32 to both sides of the equation. Doing so will give us x squared equals 36. To solve this equation x squared equals 36, we will use the square root property, which says that if something squared equals a number, that something is either equal to the positive or negative square root. In this case, if x squared equals 36, then x equals 6 or x equals negative 6. We can finish off with the solution set notation to identify the solutions as 6 and negative 6. In part B, we need to solve the equation the quantity x plus 5 squared equals 0. Since this equation is already set up that we have a variable term that is squared equal to a number, we can immediately apply the square root property. Now, the square root property would normally say if something squared equals a number, that something is either equal to the positive or negative square root of that number. In this particular case, that would say that x plus 5 is either equal to the positive or the negative square root of 0. But the fact is, there is only one square root of 0. It is neither positive nor negative. So in applying the square root principle, we end up actually with only one possibility, that x plus 5 has to equal 0. And to solve x plus 5 equals 0, we simply end up with x equals negative 5. Again, finishing off with that solution set notation, the solution set here is the set negative 5. You should hopefully notice the first equation we solved had two solutions. More often than not, quadratic equations, ones that have that x squared as their largest degree term, do have two solutions. But occasionally, they sometimes have one real solution, in this case, negative 5 on part B. In part E, we're going to follow the same process we used on the first two parts. We're going to isolate the squared term and then solve it using the square root property. In part C, we have x squared plus 4 equals negative 12. To solve that, we'll begin by subtracting 4 from both sides of the equation, giving us x squared equals negative 16. By trying to apply the square root property to this equation, x squared equals negative 16, we end up with either x equals the square root of negative 16, or x equals the negative square root of negative 16. What we should recognize at this point is that that negative 16 that's involved in both solutions is not a real number. And what that tells us is that this particular equation has no real solution. The main focus of this video is to recognize that when you are solving quadratic equations, those equations can have either 2, 1, or 0 real solutions. We will spend the rest of this section investigating that third possibility when there are no real solutions.